Oh.
Yeah.
Oh my goodness! No, in 2 minutes, 2 seconds. Oh my god. Hello everyone. Welcome back to Brown Track. I got my times a little bit mixed up. I thought we had another 5 minutes to discuss, but this is Pragati. She's going to be talking about the basics of GraphQL, something very near and dear to my heart. I've had a lot of both horrific and wonderful experiences with GraphQL, so I'm excited to hear about that. Again, if you've got any questions, leave them in the Q&A, and I will read them out at the end of the talk. If you leave a question, I think you'll get go into the draw for some packet books. That's right. Anyway, I'll leave it to you now.
Awesome. Thank you, James. I'll quickly share my screen so that we do not waste time. And it should be up now. All right then. Welcome everybody to the talk. So today we are going to talk about exploring GraphQL since it is relatively a very new concept for a lot of us. I'm pretty sure as QAs we've had the chance to work on REST APIs, but GraphQL is a relatively new concept in the industry by and large. And previous year, from the past 1.5 years, I've been working in GraphQL. I've explored why do we need to have this? How do we need to shift our mindset with respect to having a better test coverage when it comes to GraphQL? And that is all what we're going to talk about in today's session as well. So we'll start off with the basics. We'll see how GraphQL is different from REST APIs, in what all different scenarios do we use GraphQL, and what all different scenarios would you prefer REST over GraphQL. So we would talk about everything around those lines. And then, of course, the main aim for us is to talk about how QAs would have to test things differently when it comes to an architecture which potentially uses GraphQL. Just before jumping onto the content, a little bit of introduction about myself. So I'm Pragati, and I am associated with ThoughtWorks from the past 2.5 years. I have a total of 5.5 years of experience as a quality analyst. Recently, I've made a paradigm shift of moving into business consultancy role. But here as well, I'm actually leveraging a lot of the different skills that I honed up in my QA journey. And that's really helping me out because at the end of the day, what we all need to do is deliver products with quality, and that is the intent no matter which role you are in. So quickly diving into the content of the talk today. So I usually put it this way, that if GraphQL had a tagline, it would definitely be nothing more, nothing less. And why do I say that is something you'll get to know in the follow-up slides as well. But just to give you a glimpse of what exactly it means when I say nothing more, nothing less, whenever we want to have a response back, whenever there is an application and it looks for certain kind of data that is to be put as information over to a web application or a mobile application, we would want to make sure that we are not overfetching information because, of course, there are a lot of performance constraints that are involved with that. And we're not underfetching as well, because if we would underfetch, we are actually not giving the relevant information out to the public or the audience. So we need to make sure that we strike the right. That is precisely what GraphQL does for us. In the follow-up slide with a lot more examples, we'll get to know how this fits in the picture. And I hope it would make more sense why I use this as a tagline for GraphQL once we jump onto those slides. Starting from the basics, of course, let's just see how the API real-world analogy like for us. And this is a typical example that I use most often than not. So we all know that what is an API? It is basically an intermediate between a client and a database. So whenever we have a client, which could be any of our applications, be it web applications or mobile applications, it would have certain requests from getting back information from a storage, which is a data. Is that medium through which they actually get back information? That medium is an API. So that could be any kind of API. That could be a SOAP API. That could be a GraphQL API. So it doesn't matter what the nature of the API is. So API, by and large, which is the application programming interface, is an intermediate between request from the client, taking it back to the data, getting back some information from the database, and then finally giving out that as a response to the client itself. Now, just let's talk about a real world example to drive an analogy between this. So whenever we go to a restaurant, we place an order, and this order is prepared by the kitchen or the chef. So let's suppose there's a client or a customer who has entered a restaurant. They would not simply go to the kitchen and say that I want to have this thing. They would not place an order to the kitchen. A waiter who would come to their table, would take their order in, and would go to the kitchen. The kitchen would prepare their meal, and once the meal is prepared, that meal would be taken by the waiter to the customer. And this is precisely what the analogy looks like. So here, the customer who has come to eat something out of the restaurant is the client, or maybe an application, which has a certain request to make. Now, this API, which is the waiter in this case, takes in that request, goes to the kitchen. Kitchen is the database for us. Gives that request to the kitchen. Kitchen prepares something, gives back the meal or the order as a part of the response. This response is then, of course, taken by the waiter back to the customer. And that is how this entire order cycle works. And that's precisely how the information cycle works as well. Now, a step further, let's take the same analogy and put this between GraphQL and REST APIs. From the slide, you'll get to know I'm a big Friends fan as well. So let's see how this differentiation is. So working on the same lines as what we called a client, an API, and a storage to be. So for us, a customer is a client, API is the waiter, and then the kitchen is the storage. Now, in the first half of the presentation that you see, so this character, he places an order to the waiter, who's Joey in this case, and he says, "Hey, Joey, can I get spaghetti pasta without meatballs, olives, and broccoli?" So this customer over here has a very specific demand, to which Joey replies, "Sorry, Ross, we would not be able to customize." So even though the customer had a very specific demands and there were certain things he did not want in his meal or in his order, but the waiter simply said that he cannot do that. He would have to take the entire thing and eat it. Or if he want to do something, he would have to do it on his own. So the waiter would not be doing any kind of customization. So he would just get whatever is available. And this is precisely what REST API does for us. So if we go ahead and if we, as a client or an application, ask for certain information from a REST API, we would actually get back all the different fields which are present. If you want to have, probably have to create a new endpoint and get back only the subset. So that means if there are like different permutation combination of fields that you want to have at different, you would have to create that many REST APIs. So only one API cannot suffice your problem statement here. Contrary to this, let's come on to the second half of the slide, wherein we have the same customer. So the application for us remains the same. And the demand, that is the request, also remains the same. That now this customer has a very specific demand again, wants to have a spaghetti pasta without meatballs, olives, and broccoli. To which this waiter on the hindsight says, "Sure, Ross, whatever you want." And this is an analogy that we can drive with GraphQL. So with GraphQL, whatever the client requests for, so if there are like 10 different fields which are or database, and you as a client only require 4 of the fields to be displayed over to the application, you would just request for that, and those are precisely the response fields that you would get out of the API as well. So that's primarily the difference between REST and GraphQL on a very high level. And that is why if we circle back to what I said as a tagline for GraphQL, nothing more, nothing less. Whatever you would ask for, that is precisely what you would get. We talked about certain real world analogy, but that is now not how the real world works, actually. We would have to code as well to get there. So let's just look from this example how the different request and response structures look for REST API and then for GraphQL API. I'm pretty sure all of us are very well versed with the ones that's there on the left hand side, which is the request response structure for a REST API. So there is a, you would have some domain name, and then there is of course the object name that you're looking for, or the resource name. So here what we are trying to get is a list of all the different TV series which are present in our database or in our storage. So we are getting it, that is we are trying to retrieve some information, and this is basically a get all call wherein we want to have all the TV series information which is there in the database. And if you just hit this request, the response that we would get would be an array of objects. And within that object, we would have different fields. So we have ID, we have name, we have genre, we have a lot of fields, so on and so forth. And we would be seeing all these different fields for every object that you see in this array. So the first one would just Sherlock. You see all the different fields with all the different key value pairs. Similarly, for the other ones, you see them as well. Now, on the other side, if we move on to the right side of the screen, this one is the request response structure for a GraphQL API. So when we talk about a GraphQL API, because we have talked a lot about having the flexibility to customize your request for you to get exactly what you demand for in the response, that means that you'll have to make your request a little more verbose. You'll have to be very specific when you make a request. And if we look at the method, the only method that GraphQL uses is post. That is precisely because in the request body, you would have to ask for the customization that you're looking for. So unlike REST, wherein you actually use different HTTP methods like get, put, post for all the different operations that you want to do on your resource, it's very unlikely that you do that with GraphQL. The only HTTP method that GraphQL uses is the post method. So we use the post method, we have a resource name. And then another thing which is very different in GraphQL is the usage of keywords. So instead of using different HTTP methods for telling the server what kind of operation is to be done, it uses different keywords. So there are three keywords that basically uses. It's query, mutation, and subscription. I'll just keep subscription out of purview for the sake of this talk because it's a little more convoluted than query and mutation. So I'll just restrict my conversation to what exactly a query means and what exactly a mutation does. So out of these two different keywords, query is the one which helps you retrieve information. So if we look at it literally as well, so query basically means asking for something. And query is basically asking for any kind of information. It could be specific to one particular object or all the objects which are there on your database. So query is basically what it does in terms of if you want to draw a comparison. So whatever get does for you is what query would do for GraphQL. So if you want to basically ask or retrieve information, you would use the keyword query. If you want to change any kind of information, you would use the keyword mutation. We'll talk about mutation in depth after a few more slides, but let's just talk about query for a little more while here. So we have query. Query basically means that you're asking for some kind of information. And what is this information that you're trying to ask for? Now, this is the object that you're looking to get out of this query, which is TV series. Within that, you're just looking to get back certain fields. You do not want to have all the fields which are there. You want to have just a subset of those fields. So there's just ID, name, and genre, and that is what would be a part of the response as well. So like we mentioned, so if you want to have a subset of those fields and if you want to have different permutation combination, GraphQL is the way for us to go ahead with. And just talking about a use case wherein we could actually use all of these different subsets. Now think about an application wherein the homepage just shows you some of the information. And when you click on see more, that is when you see all the information which is available. Which means when you traverse to this application on different pages, for the same object, maybe for a TV series, you're showing some information on one page, all the information on some other page, and some other information on a third page, maybe. So that means for the same object, you want to show different amount of information across pages. So for that, it would make more sense for you to specify that from the client side as well. What exactly do you need on a particular web page? And that is where GraphQL basically comes into action. If you were to do the same thing using REST, you'll have to create three different endpoints, call those three different endpoints at those three different pages, and that would be the way for you to go ahead with. Then coming on to another example again. So we talked about a scenario wherein we want to get all the resources. Now this one is about getting a specific resource by ID. So this is an example of get by ID. So if you see the domain name is, we have TV series, and then there is an ID which is attached to your URL itself. And that is how REST works, right? So now out of all those TV series, if there's just one particular ID that I'm looking for in order for me to get that information, that's how I would have to specify that in my get by ID call. So if I hit that up, I would get back a response for only that specific TV series and not for all of the TV series that I got back earlier. Similarly, if you want to do the same thing in GraphQL, what we would have to do is we would have to add certain filtration criteria. So post, which is the HTTP method, remains same as we did in the last example. query, which is the keyword, remains same, because here as well, you're not changing anything. You're just asking for some information. So the keyword would remain query. Then we have the same object because TV series is what we're looking at. But additionally, what you would have to do is to provide a filtration criteria, which in this case is the ID. So specific to this ID, you need to get some information. And this is all the information that you're looking for. So you're looking at name, genre, IMDb ratings, and characters. And in the response, you'll get that for that specific TV series with ID 4 times 1, and only those fields that you actually asked for. So that is how get by ID would work with GraphQL, only if you just put in a filtration criteria and you should be good to go. So this basically brings us to our first poll. I'll quickly launch that poll up, and I would really love if all of you could just answer that. So I've just published a poll over, and if we could just take like 30 seconds to answer the poll. Let's just wait for 20 more seconds and then we can look at the results. I'll just quickly repeat the question. So what result do you expect from a query with no filtration criteria? That basically means that here, if I do not provide an ID and if the query remains same, what would I get? Would I get no response at all? Would I get all the different objects that exist in that resource? So would we get all the resources out of it? Or would we get an internal server error? Let's just take 5 more seconds and then we can see where we are. All right, I guess we're good to go. I'll quickly show the results as well. So 72% of us, we say that it's get all resources. And 21% say that it's 200 with no content. And then 5% have chosen the option 500 internal server error. So the right answer to this is B, wherein we would get all the resources. So this is basically tied to the last example that we saw. So this one, right, wherein there is no filtration criteria. So if you would not give any filtration criteria, it basically becomes a get all call. So you would get all the resources which are available for that particular TV series. And then that is what we're expecting as well out of it. Cool. Thank you for answering. Moving ahead. Now let's see that how can we compare different REST HTTP methods with the GraphQL keywords. So we talked about query being something which could do the function of what get does in HTTP. So get is basically for us to retrieve any kind of information, and that is what query does in GraphQL. With respect to any changes that we would want to make to a resource, so it could be creating a new one, existing one, updating some bit of information from an existing resource, or deleting the resource altogether. So for all of those different business operations, we would be using the keyword mutation instead. And for that, we have an example up in the follow-up slides as well, wherein we can talk about how mutation is used and how we already know how query works, but we can talk more about how mutation works as well. So mutation and query are the two different keywords that GraphQL has, and which basically performs all the business operations that different HTTP methods in REST API performs. So now since we've established what exactly GraphQL means, how is it different from REST, how are the different ways of working with REST versus GraphQL, different methods, different keywords. So we've established our basic understanding. Now let's understand that how do we test GraphQL APIs, and we would be using different Postman test snippets for us to understand it a little better. Go for it. Uh, So the first question that should come to our mind is what needs to be done differently. So when we're working with GraphQL API, at the end of the day, these are APIs. And all of us have already worked on SOAP or REST. So we have a pretty good idea about how do we test different APIs. And we also are aware about different tools that go ahead in terms of the usage of or testing of the APIs. So we might have used Postman, we might have used Cypress, Tyco, Nightwatch, all of these different tools that are in the market. So the tech stack or the architecture that we would want to use as a part of our testing strategy would remain almost on the same lines as we did it for the other APIs. The only difference that we can potentially see is how differently can you create a test suite for you to have coverage and also at the same time for you to avoid redundant assertions, because there are a lot of things which are happening differently in GraphQL APIs in comparison to the method structuring in order to how your request is getting structured, the usage of keywords. So while deciding and designing your test strategy or the test suite or the tech architecture, you have to keep in mind all of these different nitty-gritties of different ways of working of. So I could come up with these five different kinds of tests or the different types of ways or differences in terms of how the test should be designed for GraphQL APIs, and we can just quickly traverse through each one of them here in this slide, and then we can take a deep dive into each one of them with few examples and code snippets. So the first one is schema validation should be with respect to the request body, unlike REST. So one of the most important thing that becomes a very essential part of GraphQL API is schema. So everything is schema driven in GraphQL. So all the keywords that you see behind all of those keywords are different schemas which are doing the functions, which have different handle functions in Vibe, and all of them have a different business operation as well. So that's the beauty of it. So schema is something which drives the GraphQL APIs. Also, when we design our test cases, the schema would more or less depend upon what request you're making. It is not going to be a one size that fits all. It would differ according to the request that you create. If you have five different fields, all of those five fields would become mandatory. If you have listed six fields in your request, those six fields would become mandatory. So the schema would keep on changing according to your request body, and it would not be something which is one size fits all. So we'll have to take care about designing a schema validation in a way that basically suffices to how the request is getting structured. So that's the first thing. The second one is assertions based on HTTP codes are irrelevant since all calls send 200 OK. Just a word of caution here, a lot of it also depends upon how we are creating the GraphQL APIs, because few of the development teams they have like an orchestration service in between wherein they take in GraphQL APIs, they use it in a way that it responds with different response codes in terms of us having 2xx for valid request, 4xx for any kind of client errors, and 5xx for any kind of server errors. But if you look at the convention for GraphQL, GraphQL always sends you a 200 OK response. If something just breaks, it sends you a 500 response, but it's either 200 or 500, usually, conventionally. But of course, it would depend upon how you create the GraphQL API and how the development team wants to go ahead with this kind of nomenclature as well, in terms of having just 200 OK as the response code. But in the project that I work in, we had it this way. We had it really conventionally, wherein we had 200 OK as the response for even the failed calls. The only difference was that if there was a call which was an invalid call, which was a bad request, we used to have an additional node called error node, and within that error node we used to have all the different information of all of these errors, why do we have this, what went wrong. So all of that becomes a part of the error node, and if everything is working fine, if that call is a valid call, the only node that you would get would be a data node. So that means that instead of relying on the response code, we had to rely on the presence of different error codes within the response. And that is again something we would take a deep dive into. The third one talks about designing test cases around business functionality and not HTTP methods. So usually, whenever we work with REST APIs, this is a very common mindset that how we segregate our test cases are on the basis of HTTP methods. So we would start off with like a post call. We'll include all the scenarios for a post. Then we'll go on to a get wherein we'll retrieve the created resources. Then we'll do a put and then we'll do a delete for us to cover the API lifecycle as well. So that's really the way we usually do it, by segregating our test cases on the basis of HTTP method. In REST, it actually works for us simply because every HTTP method is kind of tied back to a business operation. So if we talk about get, it is actually retrieving information. If we talk about create, it is actually creating some information. So in a way, all of these different methods are tying back to business operations. So it couldn't really harm us in the way we designed our test cases that way as well. But this thing would not work with GraphQL because this one is keyword driven. You cannot segregate your test cases by query versus mutation because that would just logically make no sense. You would have to basically drive your test cases through the business logic, wherein you say that you are, in case of TV series, right? You're creating a new TV series, new TV series. You are retrieving information of an already added TV series. So that is how you'll have to design your test cases, and not on the basis of keywords or HTTP methods. The fourth one talks about assertions should include permutation and combination of request parameters, because again, it allows you to do a lot of customization, a lot of nested customization as well. So you'll have to be careful as to checking permutation combination of different request parameters, but at the same time you need to be sure what is just enough for you, because there could be n number of cases that would become a part of this permutation and combination of request params. But you'll have to be really conscious about the fact what is just enough for your application, what are the most important fields that you have, what are the most important combinations that are usually called from a client. So all those decisions would have to be made by you when you design your test cases as well. And then the fifth one talks about assertion on ordering of data. So here, because you are actually providing certain parameters in your request and you would state the different fields as well, whatever request you give in the form of ordering of the field. So if you put an ID and then name, that is the way your response would come out as well. So it would not get juggled up. The order would remain same. So that could be another assertion that you could put, that the order in which you asked for information is precisely the order in which you're getting back the information as well. So that would be another kind of test case that can potentially become a part of your GraphQL testing suite. Since we've just skimmed through all of these five different things that we can do differently, let's quickly dive into each one of them, starting off with the first one, which is schema validation. So the example that we are going to take here is getting a book by ID. So because we are getting a book, we are retrieving an information. The keyword that we would be using is query. And book is the object that we're looking to get back. Because this is by ID, you're looking to get back information of a specific book, you'll have to provide the filtration criteria as well, which is the ID, and this is a UUID. What you're looking to get back as a response is name and ID, and you should precisely get it in the same order as well. And if you look at the method, it's post here, and this is a super endpoint. So GraphQL basically works in a concept of super endpoints. So your endpoint remains same. The only differences that are there are in the request body. So if you want to query something, you would use the keyword query. If you want to get something, you would use the keyword query. If you want to change something, you would use the keyword mutation. And then whatever information you're seeking is what would go into the request body. But your endpoint would always remain the same. So if you're going ahead with GraphQL, you'll just have one super endpoint, and that is all you need to configure with the application when you use GraphQL APIs. So that's the example we're going ahead with. Now let's see how can we validate a schema. So whenever you hit this request, you'll get back a response. So the first time you do it, you would have to make sure that the response you're getting is the schema that you're looking at. So what we'll have to do is, as soon as we get back a response, what we need to do is that we need to compare the response with the actual schema that we're looking at. And what is the schema we're looking at? We're looking at a schema which involves name and ID are two mandatory fields, and that is it. We're not looking for any more fields. We're just looking for the right amount of fetching from the storage. So the schema should fail if you get back more fields than these two fields. If you get back lesser fields, then also your schema should fail. So your schema needs to be designed according to how your request looks like, and not something which is all throughout there common to all the different endpoints. That doesn't work here. The schema is strongly attached to how your request is formed. So now the response that you have gotten, you'll just save that response into a variable. You'll save your schema as well into a variable, and there are a lot of different schema creators and generators which are available online. So once you know that this is a schema you're looking for in terms of response, you can take the response, you can quickly create a schema, and then from now on you can use that schema as a stencil and compare whatever subsequent responses you're getting for the same call. And then you can of course see if the response that you're getting is sufficing the schema that you have in place. So we have two objects now. We have a JSON data object, which is your response that you would get every time you hit this call. And then you have a variable schema, which is a JSON schema of what you are expecting out of it. And then you've written a test case which says we need to validate the book schema. And TV4 is basically a function which is given by child library. So all of this is written in JavaScript. So you would need to have like a little of hands-on experience on how JavaScript works, but it's pretty easy for you to just get well versed with it. Also, there are a lot of automated functions which are available, a lot of suggestions that Postman gives us as well. So it makes that learning experience really smooth. So yeah, having said that, TV4 is the library we use for validation, and now we would validate the response that we are getting against the schema. So if it's all good, it would give you, of course, a successful test case. If it fails due to XYZ reasons, it would show you a failure. And that would be a red flag for you to see what went wrong into your response. So that's about schema validation. Becomes one of the most important test cases that we should definitely have in our test suite, and we cannot do without it. Then we have HTTP response code assertions as well. So we talked about more or less every GraphQL API sends you a 200 response. So it really doesn't make sense for us to have this as an explicit test case where every time you're checking that you're getting a status of 200, because that is what you're expecting out of all the calls, be it a failure call or a successful call. So this would not be a differentiator for you. So even if you just get rid of this test case, it would not change a lot of things for you because it's kind of redundant for us now. But what would make sense is to check the presence of the error node for sure. So you'll need to check in your test cases that there are. So if you are expecting a test case to be a failure scenario, because we define our test cases with happy paths, then alternative paths, and then unsuccessful paths as well, sad paths. So if you're testing a sad path scenario, you would expect it to have an error node because you're expecting it to error out. So in that case, you'll have to check that there are two nodes available, error and data, and that would potentially become a test case for you. Similarly, these are just two different snippets of you identifying the existence of error nodes. So you can go either ways. Or you can, of course, have your own piece of code as well. The only intent for us is to check the presence of error and data nodes in case we are working on the SAT paths. So now this one was the second recommendation that we have in terms of designing our test cases for GraphQL. Moving on to the third one, which is designing test cases around business functionality and not around HTTP methods. For REST, because every business functionality is categorically related to a REST method, so it just works for us. If you do it via method or if you do it via business functionality, it wouldn't make much of a difference. But if you talk about GraphQL here, right, because this is keyword driven, so you would have to go the other route. You'll have to make and design your test cases on the basis of business functionality and definitely not on the basis of keywords. So the first case could be that you're creating an entity and it can have all the different flows or scenarios. Then you can have another one where you're retrieving information. And then, of course, with each of these different business functionality, you can take it and use different keywords as and when these are required. But of course, you cannot design your test cases by segregating them into how query would function versus how mutation would function, because that wouldn't make a lot of sense for you to do it that way, because you're not essentially testing an API journey, you're just testing API keywords, which is definitely not the intent of how we design our API test cases. So there's another poll that I'm quickly going to launch, and let's just take about 20 seconds for us to answer it. So it is a pretty basic question. Is it a good practice to create the API test cases by dividing them on the basis of HTTP method? And it's a Boolean question. Is it a yes or a no? Let's just quickly wait for a couple of more seconds. and then we can quickly move ahead to the next part of the slide. There is a close competition between yes and no is winning right now. I'll close the poll in about 15 seconds. Cool. Let's just take 5 more seconds and I'll show the and we have the results. So 57% of us, we say that it is not a good practice to create API test cases by dividing them on the basis of HTTP methods. But 43% of us do say that it is a good practice. So the answer to this is no, it is not a good practice, because at the end of the day, every API is linked back to a business use case. And be it a UI test case or an API test case, everything needs to be driven by business value and by the business user flows. So, because even if you look at an API, it essentially is meant to do a business operation. So, if we talk about a book, right, if you want to create a new book, there's just like a tech behind it, which is in the form of an API, but it is performing in business operation. So, whether it be a REST API or a GraphQL API, our intent should always be to drive our test cases through the business logic and not through the tech logic. So that's always a good practice if we do it by using the business functionality first and then figuring out how the tech works behind it. All right, moving on to the fourth one, wherein we said about having assertions and having different permutation and combination of request parameters. So here we are using another example, which is of a mutation. And since we talked about mutation, doing any kind of changes, right? So it means if you want to create a new resource, you'll use mutation. If you want to maybe update a resource, you'll use mutation. If you want to delete a resource, then also you'll use the keyword mutation. I talked about this being a super endpoint. This one would remain static. This one would remain same. The method would remain same as well. The thing that has changed here for us is the keyword. Now, coming to this add book. Now, every keyword has a handler in between. So there is a handler, and this handler talks about adding a book. There could be another handler which talks about updating a book. So you can think this as a function. So add book is a function. It is taking certain parameters with it. So it's taking a name, it's taking a genre, and it's taking an author ID, which is a non-mandatory field. So you can just simply put it as a blank. So think about it as a function, and at the back of this, there is a code which is written in our repository, which talks about adding a book and adding a book to the storage, and then getting back some information after the book has been created. So this is the response fields we're looking at, name and ID. And let's see how do we actually test the different permutation combinations. So the first thing that we can validate is, of course, the data, because here precisely in this function, we have called out that we need to send Tuesdays with Muri as the name of the book. And we need to have data assertions as well, because you have requested for a certain name and this is the name that you should get back in the response as well. So the first assertion that becomes an important part would be a data assertion. We do that for REST APIs as well. So this is like a conventional test case. The other one is the presence of fields. Now here we just looked at calling name and ID as the fields in our response. So we'll have to check that we do have these different keys. You can of course create a different test case altogether, wherein you have name, ID, and genre as the fields that you request from the response. Then of course you'll have a different test case altogether, wherein you would check that 3 fields are there and not just 2. So you'll have to keep in mind, and you'll have to take that conscious call to which level of depth do you want to go with respect to these combinations, and what all combinations are essential for you to test as well. Because there could be like unlimited number of combinations when it comes to GraphQL. So you'll have to take that conscious call as well, because you need to keep that layer lean. You cannot bloat it with putting in everything and anything. So that's another conscious call that we would have to take when we design our test cases. Coming on to the last one, which is assertions on ordering of data can be validated. We would use the same example that we did for the other part, wherein we checked the presence of all the different keys. Here, like we mentioned, in the mutation, we provided that the order should be name and then the ID. And this is precisely the order that we're looking to get back in the response as well. This is again a little snippet wherein we have an expected key order. How do we know the expected key order? Because we are the ones who created the request, so we would know what the expectation is. Whatever response we would get, we would just put that up in the actual key order, and we can traverse this array and see that the 0th index matches with name, the first index matches with ID, and if that matches, so we're good to go ahead, and it basically tells us that whatever order we were expecting is what we are getting back as well. So that's another test case for us. So now we've completed with all the different 5 recommendations we looked at. So just quick key takeaways from whatever we discussed in the past 30 odd minutes. So GraphQL is definitely a good fit for complex systems and microservices, but it might be an overkill for small and simpler systems. So now if you have a very basic application which wants all the information from the database, need for you to go ahead and do an overhead of creating a GraphQL call and then putting in all the request parameters. You can simply achieve that using a REST API. But if you have a complex system which is using different amount of information at different pages or different domains, maybe that's the potential area where GraphQL call could help you. If you look at the screenshot as well, wherein we have RESTful example. So for a request wherein you're trying to do different operations, right? So there's post to create, delete to delete, get to retrieve, and so on. You have different endpoints. Now there is not a super endpoint in REST. There are different endpoints for every request that you make. And behind the scenes, there are different handler functions which are attached to these endpoints. Now, if you look at GraphQL, there is a request, there is a super endpoint which just goes like slash GraphQL. But internally, using the different queries and different methods, it has different handler functions. So there could be create, there could be delete, get, update. So all of these handler functions are attached to the super endpoint. And that brings us conveniently to the second point, which is fetching data with a single API call. So using a single API call, integrating that with your application, you can actually do a lot of things with using GraphQL. Again, let's just quickly take the last poll for today. So the question is, what would you prefer for an application that displays different information across different pages? So would you use REST or would you use GraphQL? And that's the question that we have. Let's see. Let's just take 15 seconds for us to answer this, and then we can look at the results and go ahead with it. Meanwhile, I can just elaborate more on what the question is. So if you have an application and on the home page you want to show just information from 3 different fields, like if you talk about a book, I just want to know about the book name and the author. But when I click on the book name, I would be navigated to a different page wherein it would show me the entire information about the book. So in such a scenario wherein different pages are showing different information, is it ideal for me to use GraphQL or should I use REST? All right, let's just take 5 more seconds and look at the results. I'll show the results now. So 57% votes to GraphQL and 43% votes are given to REST. So the answer to this is GraphQL. Like we said, for systems which are using different information on different pages, that means that you would have to create those many endpoints if you go ahead with the RESTful approach. So if you want to have 10 fields, you'll have one endpoint. If you want to have 5 fields, you'll have another endpoint. But with GraphQL, with just one endpoint and different request parameter, you can achieve that really easily. Also, it would depend upon the number of pages you're looking at. If there are like just 3 4 pages, you might as well just use REST. But if there are like 20 odd pages, you should definitely, without any inhibitions, should choose GraphQL. Some more key takeaways. So no overfetching and underfetching problems with GraphQL, like we discussed. All the requests are tailor-made. So whatever customizations you want to do, you can do that using GraphQL. Validation and type checking out of the box. So like we saw on mutation, right, wherein there was a function that was taking in parameters or input parameters of fields. So in that case, if you would provide a different type of the field, so if there is a field that looks at having integer, but if I provide string, as soon as I hit the GraphQL call, it would actually give me the error out of the box that there is a type mismatch. So all of these type checking validations are something that GraphQL gives us out of the box. Also, there is auto generation of API documentation. In RESTful, you would have to have integration with like OpenSpec document or Swagger for you to have a list of all the APIs as documentation. But with GraphQL, there is a flexibility with GraphQL, and that actually gives you an auto generation of documentation wherein you can look at all the different methods available, handler functions, what are the different queries, what are the different mutations that you have, and you can simply design your request in a very simple. Then error messages, because we have these two nodes, right? So there's error node and then there's data node. Within the error node, they actually provide you a lot of verbose messaging that helps you to have a better troubleshooting in place as well. But of course, everything comes with its own negatives as well. So there could be a lot of performance issues that you could see with complex queries, because with GraphQL, you can do a lot of nesting. If you do a lot of nesting and if you create a lot of complex queries, it would make your life hell, because the performance issues are a real thing in GraphQL if you go to nth level of nesting, and you need to be really cognizant how you create your requests as well. Curve is of course not smooth. It takes a little while for us to wrap our heads around the workings of GraphQL. So if there is a new team who's starting off to work with it, so delivery might take a lot more time because there would be tech understanding, there would be business understanding. So that's another problem that we usually encounter with GraphQL. So these were some key takeaways from the talk, and open to any questions or feedbacks.
Great stuff. We're just over time, but if you don't have anything to do, we can definitely answer some of the. This is by far the most popular talk thus far, so I feel like you might want to answer some of the questions. So are you free? Do you wanna answer a few? So I think Naringa asked, what language should I know to actually use GraphQL?
Mm-hmm. So for you to use GraphQL in terms of SQL and databases, these are potentially the same databases that you'll use with your REST call. So you could use MongoDB, you could use SQL, you could use anything. With respect to the language that you should know, I usually work with JS and Java. So if you have a good hold of that, it should be a pretty smooth journey for you to wrap your head around how GraphQL works. So I guess that's the way you can go ahead with.
Pretty language agnostic, yeah.
Yeah.
Someone else asks, what made GraphQL stand out? How GraphQL stood out? Which is
Oh. So I'll be really honest. Instead of standing out for me, it was more of what the project demanded, because we had like a client call which said that let's try well, because there were certain complex things that were happening. So I was working on a bank application and it required a lot of data to be processed. So we thought that let's have some kind of a newer API in terms of having a backend for front end. So we had like a BFF layer in between. Internally, we were still using REST APIs, but for us to have performance standing out in a better fashion for us, we had a BFF which had GraphQL APIs, and then they were interacting with REST APIs. With respect to what stood out for me personally would be the changes I saw in terms of the performance of that entire convoluted application. So we actually saw that the numbers increased, the onboarding became really faster for the customers. And once we made that shift tech wise, we actually saw a lot of business revenue generation as well from that.
nice. Doruk asks, is there any way to migrate REST to GraphQL? And what is the best practice? Are there any fantastic libraries that you know of?
Unfortunately, that is something which is really, really complex. So like I mentioned, so how we resolve this, because we had like a lot of legacy REST APIs already in place. We were not ready to go let them go away. So what we did was we created a layer on the top of it in the form of BFF. And now this backend for front end was basically all GraphQL. And internally they were using REST API. So it is just like a wrapper around your REST APIs so that
These are
the front
already a
end.
free migration. Yeah,
Yeah.
that's pretty good. We've got 4 more if you still want to keep going. It looks like there's a need for knowing internal function names to call them for testing. Is there any support for listing existing functions and their required available fields? Oh, this is a strength, I would say, of GraphQL. So what do you think?
I guess the last big that we talked about in terms of key takeaways, right? Wherein we have GraphQL in terms of having the API documentation. That's the best way for us to start writing our test cases from as well as a point of source of truth. So you can use GraphQL as your source of truth. You can go ahead with the schema, and there is where you would get all the function names. And that's the right way for you to start testing your GraphQL APIs as well, in terms of designing your test cases.
Yeah. You can normally get the types if you use TypeScript or Java or anything. The types are available. So easy to use. And then let's see, we've only got one more. Why should we test response keys orders? What problems wrong order could cause? Test the
Yeah.
response
So
keys order.
with respect to the ordering, what usually happens is that it also depends upon how your client is consuming the information from GraphQL. So if you're not keeping it specific to your key names, just keeping it specific to your indexing, which could be the case in GraphQL, because yeah, now you know that whatever request you're sending should abide to the index as well. So if you've designed your front end code in a way which matches up to the index, and if the order flips out, your entire front end would kind of break. So that's the need for us to maintain that order in place in our test cases as well.
Nice. So there's 2 more, but I'll wrap them up into one. Can we use SOAP UI with GraphQL, and do we need an extension to Postman to work with GraphQL? Pretty should be pretty straightforward. Postman, like no, but I don't know about SOAP UI. Do you know?
No, I don't think so, because we cannot use SOAP UI with GraphQL.
Oh,
I've
okay.
never worked with it though, but yeah, I don't think
Yeah.
so.
No. Well, that closes it off. We're a little bit over time, but I think everyone enjoyed this immensely. So thank you for your time. Thank you, everyone. We'll be back in under an hour now. Thank you, Pragati, and that's all,
Thank you.
folks. See you around.
Thank you. Have a nice day. Bye bye.